Have you ever wondered how our planet transformed from vast, frozen landscapes into the diverse terrains we see today? Welcome to our journey through the end of the Ice Age. To comprehend the world of the Ice Ages, imagine an Earth painted with white expanses. Ice Ages are epochs when the Earth's temperatures drop dramatically, resulting in vast sheets of ice blanketing our continents. The Earth's relationship with Ice Ages is not just a fleeting romance, it's a recurring dance, spanning the annals of geologic time. Over the last billion years, our planet has been encased in ice at least 5 times, painting a picture of cyclical periods of chilling cold and relative warmth. Now, what prompts this cyclical dance? The answer lies above us, in the vast expanse of space. Our Earth does not merely orbit the Sun in a simple, fixed path. Instead, its orbit undergoes subtle changes over time, influenced by gravitational interactions with other celestial bodies. There are 3 primary orbital variations at play. Eccentricity. This refers to the shape of Earth's orbit around the Sun. Over tens of thousands of years, it transforms from being nearly circular to more elliptical, changing the distance between Earth and the Sun. Obliquity, tilt. The Earth's axis isn't straight up and down, it's tilted. This tilt can vary between about 22.1 degrees and 24.5 degrees over a 41,000-year cycle. Greater tilts mean more pronounced seasonal changes. Precession. Think of a spinning top. Over time, the direction it points can wobble or shift. Similarly, Earth's rotational axis wobbles, affecting which part of Earth is closest to the Sun during different times of the year. These variations, collectively known as Milankovitch cycles, influence the amount and distribution of sunlight or solar insolation that the Earth receives. When conditions align such that the Northern Hemisphere, with its vast land masses, receives reduced summer sunlight, ice sheets can grow. Conversely, when it receives more sunlight, these ice sheets retreat. By understanding these intricate celestial dances, we gain a deeper appreciation for the Earth's climatic rhythms, shaped by forces beyond our immediate perception. Did you know? We're still in an ice age called the Quaternary Glaciation. Though we're currently in a warmer interglacial period, it began around 2.58 million years ago. About 20,000 years ago, during the last glacial maximum, vast sheets of ice enveloped North America, Northern Europe, and Asia. This icy grip transformed landscapes, redirecting rivers, carving out valleys, and pushing up mountain ranges. The Earth's climate is an intricate waltz of various elements. Small changes like shifts in the Earth's orbit, volcanic eruptions, or even asteroid impacts can plunge us into these frosty depths. During this time, creatures like the woolly mammoth, with their long, shaggy hair and large, curved tusks, thrived in the cold, becoming icons of this frozen epoch. With time, our planet began to warm. This big thaw was set in motion by a combination of Earth's changing tilt, increasing greenhouse gases, and natural climate variability. As the ice sheets melted, they released vast amounts of fresh water into our oceans. The thawing period spanned thousands of years, resulting in a transformation of our planet's topography and climate. Sea levels rose, potentially by over 120 meters, drowning coastlines and creating the continental shapes familiar to us today. This great melt didn't just reshape our physical world. It also altered ocean currents and wind patterns, creating new weather systems and climatic zones. The melting ice dramatically altered our planet's face. As the ice retreated, vast plains, forests, and new landforms emerged. Coastlines shifted, islands birthed from the seas, and land bridges, like the Beringia between Siberia and Alaska, were submerged. These changes weren't just geographical, they also influenced migration patterns of both humans and animals, allowing species to spread, mix, and adapt to new environments. It's believed that the Bering Land Bridge, now below the cold waters of the Bering Strait, was a pivotal migration route for early humans, leading to the settlement of the Americas. The retreat of the vast ice sheets marked not just the end of an era, but the dawn of a new epoch of life on Earth. As the ice relinquished its grip, it unveiled vast expanses of barren land, a blank canvas awaiting nature's touch. Imagine a world reshaping itself. As temperatures climbed, previously frozen terrains became fertile. Torrential rains began carving rivers through the lands, lakes formed in depressions, and soon, seeds carried by winds, water, or animals took root in these freshly minted soils. The rapid proliferation of plants converted large areas into sprawling forests, while in regions with less rainfall, grasslands and deserts began to form. Deserts might seem life-sparse, but they soon became home to specially adapted species that thrived in aridity, from cacti to camels. Rainforests arose near the equator, their dense canopies and layered ecosystems supporting a vast array of life, from the tiniest insects to towering trees and elusive big cats. Grasslands stretched across different continents, their open landscapes welcoming herds of grazing animals like bison, antelopes, and their predators. Each of these ecosystems didn't just exist in isolation. They were intricately connected, influencing and being influenced by one another. For instance, the grasses of the savannas evolved alongside the herbivores that grazed upon them, leading to a dynamic balance. The post-Ice Age world was a crucible of evolution. Species that could adapt to these new environments flourished, leading to an explosion of biodiversity. This period of rapid diversification and adaptation crafted the intricate web of life we see today. Every plant, every creature, every ecosystem has its roots in this transformative epoch. As we look around us, we're not just witnessing the present, but the echoes of a past where the Earth, emerging from its icy slumber, embraced life in all its myriad forms. Our planet's history of ice ages and thaws holds profound lessons for today. As we grapple with human-induced climate change, the melting of polar ice caps and rising sea levels eerily mirror Earth's natural rhythms. The difference now is the pace and the profound influence of human activities. Understanding the ancient dance of ice and warmth can offer insights into the present and help us navigate potential futures. Ancient ice preserved in glaciers holds bubbles of ancient air. By studying these, scientists can learn about past climates, offering invaluable data for climate modeling and forecasts. In tales passed down through generations, ancient civilizations spoke of times when the world was draped in ice and of epochs when it was reborn from its icy slumber. These tales remind us of the resilience and adaptability of life on Earth. Our planet's history, marked by ice ages and thaws, is a testament to nature's power and persistence. As caretakers of this blue gem, understanding our past is crucial to cherishing and safeguarding our shared future.